So for organic chemistry, it's really important to know the specific reagents that cause molecules to become oxidized and reduced and that sort of thing. So an oxidizing agent is an element or a compound or molecule that accepts an electron from another species. So essentially, oxidizing agents get reduced. And that's a really important concept that can be really mixed up. And likewise, reducing agents would get oxidized. So for Orgo, we want to know, okay, what's going to cause these oxidations to happen. So to do that, we want to first categorize our different reagents. So we have PCC. PCC stands for pyridinium chlorochromate, and that is one of our weaker oxidizing agents. And we have CrO3, and combined with pyridine, that is also falls under one of our weaker oxidizing agents. So this will become really apparent what's weak and what's strong when we're trying to oxidize primary alcohols. So for now, I'm just going to call these weak. Then we're going to go through the strong ones. So there's a ton of strong oxidizing agents, and these include things like KMNO4, we've got H2CrO4, we've got H2O2, and that's peroxide. And we also have things like Na2Cr2O7. So essentially, you're probably seeing a pattern here. There's many of these strong oxidizing agents have a high number of their oxygens, or they have unusually high oxidation states within their other elements. So that's something to note. And I'll just throw in a few more just so you can recognize them if you come across them. 2O7 and O3, which can be combined with some other things to produce a strong oxidizing effect when we talk about alkenes. So this is our list of strong, and this is our list of weak. And what's the difference between weak and strong oxidizing agents? Well, to start off, we will have a primary alcohol. So in this case, I'm going to use the ethanol. And if we wanted to oxidize this to an aldehyde, and just to an aldehyde, that would be an aldehyde. And then we would want to use a weak. So something like PCC would get us to the aldehyde. But what if we wanted to go all the way and oxidize this to a carboxylic acid? All right, so now we definitely need a stronger oxidizing agent, probably something with more oxygens. So KMNO4 would be a great option. All right, so that's pretty much how you could sum up strong versus weak. The only thing is when you have something like this, we have R groups and OH is an alcohol, then you could use either a weak oxidizing agent or a strong oxidizing agent and you'll still get the same product. So you could use PCC, you could use KMNO4, and this should be OR, and you'll still get a ketone. So that's pretty much what that is. So here we've got an aldehyde. Here we've got a carboxylic acid. Here we've got a ketone. So it really just depends what your reactant is and what oxidizing agent you use. Okay, so here I've got a little table set up with our reactants, our reagents, and our products. So basically, if we're given a reactant and if we're given a product, we want to be able to find out what reagents can allow us to form the product that we desire. So to do this, we would start with our reactant. So here we've got a primary alcohol, and we want to get it to an aldehyde. So that looks like a weak oxidation to me. So we don't want the oxidation to go all the way through. So we could use something like PCC, or we could use something like CrO3 impurity. So these are both reagents that would just take us to the aldehyde. Now, if we wanted to go from the primary alcohol to the carboxylic acid, which is what we've shown in the next row, that's going to require a stronger oxidizing agent. We can use something like KMNO4, good option. H2CrO4, also a good option. And so peroxide, also a great option. That's for our second one. For the next one, it's the same thing. We want to go from an aldehyde all the way to a carboxylic acid, the one we've shown in green. And so I would say that we could do this again with the same reagents. So I'm just going to put a little thing there to show that we would use the same thing. And so now we've got a phenol, or sorry, not a phenol, a benzene ring with a methyl group. And we want to change that to a, I meant to put a carboxylic acid there. Sorry about that. And so now we want to get from this benzene ring with a methyl group to a benzene ring with a carboxylic acid. That's a pretty strong oxidation. We're putting an entire carboxylic acid group onto this benzene ring. And so we could use something like KMNO4, very strong oxidizing agent. Now this next one is interesting. It looks like we're splitting this alkene into two carbonyl containing molecules. So this is a special reaction known as ozonolysis, and this is usually done with an ozone molecule, and the ozone molecule is O3. And when we do it with these ozone molecules, we often will use something like zinc in addition, or even something like methyl group with a sulfur, another carbon. So that's pretty much the main oxidation reactions that I wanted to sort of cover and just give you an overview about. See you next time.